First step of finding a limit.
Drop 0 into your.
Good. So now, where does this go when x approaches 0? Perfect. Where does this go when x approaches 0?
0. Oh, no, it's undefined.
Yes, it is undefined. And first of all, it really doesn't exist from either side. It's positive infinity, negative infinity. So we have a situation in which we have 0 times something that is unknown. It could be d and e. But no, you cannot say, oh, anything times 0 is 0. No, no, we cannot say this. Okay? So it could be that 0 times whatever is 0, but we cannot conclude that from the beginning. So therefore, for this particular situation, no limit law works. It's a product. You can say, find the limit of this times the limit of this, but the limit of this does not exist. So I cannot apply the limit law of the product. Remember I said the limit of a product is the product of the limits, not here, because the limit of this does not exist. So we have to think of something else. We have to think of the squeeze theorem, part 1 and part 2. If we have those two parts, then we can conclude whatever about this limit. But we have to build those two parts first. Okay, the first part says, show that this function is squeezed between two other functions. But I have to find them. I have to find f of x and I have to find g of x. My starting point is with cosine of 2 over x. So does anyone remember where cosine 2 over x? What are those boundaries of any cosine? Any cosine. What are those boundaries? Say it again.
Is it 1 and -1?
Excellent. Excellent. So I do have, I can say this is squeezed between -1 and 1, but that's not good enough because the function is this. So what should I do to all three sides in order to have this middle part, x to the 4th cosine 2 over x? What should I do to all three sides of this inequality?
Multiply by x to the 4th.
Exactly. All three sides. I have to be careful because this has to be greater than 0, and it is. X to the 4th is always positive, and never 0, and it is. Because when we talk x approaches 0, we know this x does not equal 0. So these conditions are fulfilled. I'm allowed to multiply all three sides by x to the 4th. So negative x to the 4th less than or equal to x to the 4th cosine 2 over x less than or equal to x to the 4th. I fulfill the first hypothesis. I have the first hypothesis down of the squeeze theorem. Yay! So now the next step is I have to find the limit. So this is step 1. In step 2, I have to find the limit of f of x, the bottom one, as x approaches 0. I have to find the limit of x to the 4th, the top one. If these two limits exist and they are the same, then I know what to conclude about this based on the squeeze theorem. So, do we have the answers here based on what we studied?
I think they're both 0.
So then I will say from 1 and 2, squeezed, and these two limits exist and they are the same, by the squeeze theorem, what do I conclude about the limit of x to the 4th cosine 2 over x as x approaches 0 from either side?
It is 0.
That it is 0. Why again? The function I showed is squeezed between two functions whose limit Both limits exist and they're both 0. So that's for right here. I don't know outside of it, but as x approaches 0, it's guaranteed by the squeeze theorem. Any questions on the squeeze theorem? Okay, so for example, before we look at the absolute value, for example, how will I work on a problem like this? What is all this? See, that's another application of the squeeze theorem. The function is not even given to us. We don't even have the function. So in 39, we have 4x minus 9 less than or equal to some function f of x less than or equal to x squared minus 4x plus 7 for all x greater than or equal to 0. And we're asked to find the limit of f of x as x approaches 4 from either side. And now I say to you, find the limit without the function. You will say, wait a minute, you're not giving me the function and you want me to find the limit? Yes, because we are given the first hypothesis of the squeeze theorem. They are already throwing at us the bottom function, so function 1, and we have function 2. This is already done. We don't have to build this step by step as we did. We already have it. We only have to show the second part. What is the second part? What will you tell us or tell me to write to make sure that the second part is there? So part 1 is already there. Part 2, what do I have to write?
The limit of each of those.
Exactly, 4x minus 9. Of course, it has to be yes as x approaches 4. And the limit as x approaches 4 of x squared minus 4x plus 7. What happens if this one is 5 and this one is 10? What will I conclude about this? What if this is 5 and 10? What do I conclude about that?
Does not exist.
The theorem doesn't apply. I have no idea how to find this. The theorem, the squeeze theorem, does not apply. It may exist or not. I have no clue. So what is this and what is this?
They're both 7.
Very good. So from 1 and 2, by the squeeze theorem, what do I conclude about the limit of this function that I don't even have? I have no clue what it is.
It approaches 7.
Exactly. Not approaches. The limit is 7.
Oh, it's
Excellent. You can say the tendency of this function is 7 when x approaches 4, or you say the limit of f of x is 7 as x approaches 4. Awesome. So that's another application of the squeeze theorem. No other limit law can be applied here. Just the squeeze theorem.
Okay, I missed something. Where'd you get your 7 from?
As we discussed, these are polynomial functions. We simply plug in to get 7. 4 times 4 is 16 minus 9. So maybe it's wrong. So 16 minus 16 is 0 plus 7. I didn't check, so it's 7.
No, I get it now.
Perfect.
I see what,
Perfect.
So that's how you get 7. And
Good. So now let's also
Can you go back
choose
one?
an absolute value. Say it again.
can you go back one?
What do you mean by back one?
Go back to. Never mind. You got.
Say it again. What do you mean with go back? Do you mean to the previous
no,
page?
No, no. I didn't see it up in the corner. I'm snipping the screens with things to take notes better.
Oh, don't forget, I post this. You know that, right?
Oh yeah.
You know where to find this, right? I may be logged out.
Yes.
I may be logged out already. But you know where to find the notes. Yes, I would, if I were you, I would also take notes so I can ask questions in class, of course, absolutely. But the notes are here. So right after class, I post the videos. I wanted to show this for those who missed last time. So the videos are here and the class notes are here. Okay, so I will post them tonight, all the videos and the class notes again that we just wrote today. So If it takes a little longer, just download it. I'm not sure. I probably am logged out. It's probably screaming at me. Oh, maybe not. Okay. So if it takes too long, just download it, save it on your flash drive, computer, whatever you want. So all the notes will be posted right after class. Because as you know, we discuss them the next time, and then I shred them. I recycle them. So everything is there. Okay, what am I doing? I'm here. So I want us to choose an absolute value function because we need to work on the absolute value, and then we can go back to the difference quotient. Anyone would like to choose, or I will?
About 47.
47 is a good one. So let's look at 47. So we have the limit as x approaches 0 from the left, 1 over x minus 1 over the absolute value of x. Perfect. So in this particular situation, I have to renege what I said before. So there are different situations in which I will have to do that. It's not that we are changing the rules, but the function is totally different. So every time we calculate a limit, I said plug it in. Not now. We can't do that now. First, we have to simplify this function fully without the absolute value. So when we encounter something like this, it is mandatory. Also, when we encounter something like this, whatever it is, or minus 4 or whatever you want to put in here, we have to find the domain first. So I can only think right away about these two situations. Okay, we're not plugging in. Yes, you can say, but I can already see this is DNE. Because when you plug in -4 plus 1 is -3, the square root does not exist. It's not a real number. True, but every time we have square roots, single square roots like this one, we have to find the domain first. Here, for such a function, we have to simplify it without absolute value first.
For the square root problem, would you find the domain by just saying a negative affinity to 4?
No, I have to write x plus 1 greater than or equal to 0 or x greater than or equal to -1. The quantity under the square root has to be positive or 0.
Okay.
Good. So now we simplify this expression, this function, without the absolute value. We have to start with the absolute value that I see here. This is the starting point. Can anyone give us what this equals to? The formal definition of the absolute value. Can anyone give us the formal definition? What are the options?
Plus or negative. Either.
Absolutely. So it's x and negative x if what? Very good. If what? This is a piecewise defined function. It must have an if.
Yeah, it is. I'm just thinking.
No, that's okay. Anyone else?
Would it
I
be
know what I do.
greater than or equal to 0?
Awesome. And the other one, which is less than 0. Perfect. Awesome. So that's our starting point. Now we can build the function after we set up the absolute value of x. Now we can, knowing this, we can build the function. Let's do that. That's our next step. So then 1 over x minus 1 over the absolute value of x. Because the absolute value of x has two options, this function will also have two options. Do not write these yet. Don't rush. So if this is x, for the first option, if this is x, I cannot no longer, for x I can, but for 1 over x I can no longer include 0. Because if I include 0 here, 1 over 0 is undefined. Here, 0 is okay because there is no denominator. But now 1 over x is in the denominator. I can no longer put the equal symbol. That would be incorrect. So when we replace the absolute value of x by x, what is the answer?
Zero.
Excellent. It's 1 over x minus 1 over x, which is 0. Awesome. Stay with me because we have the second branch. Here I have no problem. It's the same, less than 0. Good. Now imagine 1 over x minus 1 over negative x. This will change into positive, so I have 1 over x plus 1 over x. What will I get?
2 over x.
2 over x. Very good. 2 over x. So now I can finally answer my problem. I'm going to copy it again here. So I have limit as x approaches 0 from the left from 1 over x minus 1 over the absolute value of x. Which of these two branches will I have to use? Do I use the top or do I use the bottom? I cannot use both.
The
The
bottom.
Exactly, the bottom because it's 0 from the left. Awesome. 0 from the left. So now we plug in. Now we are allowed to. There is no more absolute value. So let's plug in. Where does the numerator go? As we know from the limit laws, what is the limit of 2? Okay, let's go back to the limit laws. My pages are not in order. So one limit law was the limit of a constant is the constant. So then the top goes to what?
2.
Good.
2.
The denominator goes to
0.
good. And we know that this is a no-no, right? What is the sign? What is the sign of the denominator? We know that the sign of the numerator is positive. What is the sign of the denominator? 0 from the left.
Negative.
Good. So then what is the answer?
Undivided.
Negative infinity.
Yes. So let's go back for a second in our puzzle. A number over 0. A number over 0 has 3 possibilities: positive, negative infinity, or DNE. So in this case, it was from one side, and we had a positive over negative, so the answer was negative infinity. Perfect.
And to clarify, if it was both sides, it would be DNE.
But I haven't determined the other side. I have to determine both sides. It's a very good question. So if the initial question, very good question. So here's a very important comment. If the original question were this, then I would have had to determine limit as x approaches 0 from the right and the limit as x approaches 0 from the left from this function. I cannot conclude DNE. Not for this situation. But if the original limit was as x approaches 0 from either side, we already determined the one to the left and we got negative infinity. When we determine the one to the right, we get 0. Then, only then, I will say this limit is what?
DNE.
Yes. Yes. But I have to determine both. When I determine both, only when I have a situation in which x approaches 0 from one side or a number from either side, and I have these situations. Like I simplify and so on and so forth, like this problem. I determine that one side is 0, the other side is negative infinity. Only now I can conclude this. Sorry about that.
Professor, can I ask a question?
Any question, of course.
We got x for the limit for the bottom, our denominator 2 over x, or we got 0 for that. Sorry, just to your right, this bit. Yes. Wait, we got 0 for that because of rule 7, where it says if the
No.
Sorry. No.
When x approaches 0, x approaches 0.
Yes. Sorry. That
Oh, you
looks
meant
to be the
rule
same
7 from the limit?
rule 7.
Yes. It was that one with the limit of x when x approaches. Yeah, this one. Yes, of course. Yes.
Okay.
Exactly. Good. Other questions here?
Yes. So for that same spot, if the 0, how did we determine? Or sorry, if the 0 was positive instead of negative, would that make it positive infinity?
Yes. Awesome. So this is from last time. If you remember, we had this situation. The numerator was negative and the denominator was positive. So that's how we got negative infinity. As x approaches.
And when would it be DNU?
Rarely for one-sided. Rarely, unless it's an oscillating. So for example, very good question. Thank you. So this will be DNE alone, from either side or from both sides, because this is an oscillated limit. So this alone will be DNE, even if it's one-sided. In general, the one-sided you should think of and be careful as negative infinity or positive infinity. But this situation, as x approaches 0 from the left, from cosine 2 over x, this is DNE, because it's an oscillating limit. And also for x approaches 0 from the right, it doesn't matter. It will still be DNE. But in general, it's an awesome question. Thank you. In general, when we functions like these, rational and so on and so forth. So when we determine the limit as x approaches 0 from, or a number from left or right, one-sided limit, normally we will get this, either positive or negative. We get DNE in this situation when they are totally different. But there are situations in which the function is oscillating and it will not have a limit.
All right, thank you.
Very good question. Thank you.